I'm surprised that we're not just listening to the news. Hi, everybody. I'm Matt.
Hi, Matt.
Hi, Matt.
Thank you for coming. Before we get started tonight, I wanted to first of all thank SupplyFrame, that's my company, my employer, the people who pay for the pizza and for the beer and all of that other stuff. I also wanted to mention just a couple of things. So on the back table over by the pizza are a bunch of t-shirts for a website that we just launched called Parts.io. Chris Gamble is actually the product guy in charge of Parts.io, and he can give you much more detail on sort of the intimate aspects of the site and that sort of thing. But to kind of wrap it all up in something sort of condensed, it's a really cool site for actually researching components. We try to tie a lot of the sort of intelligence that guys like Chris and myself sort of bring into that process of how we actually search for components and how we actually find parts. It's not purely just going in there and actually just throwing in a part number and getting pricing information. You can do that. We aggregate pricing information across a bunch of different stuff. But it's also a place where I can actually go in there and spend some time and actually dig around and try to find the best microprocessor that or that sort of thing. Anyway, that's all the hand-wavy bits. But the t-shirts that are back there are actually for Parts.io, so you won't forget the URL. I found that it's easier to remember if you just call it Parts.io. But some people don't like that.
Some marketing guy just died.
Yeah, it just exploded right into a vapor. Yeah, so also if you guys are interested, so I started a blog, which is kind of rare for me. I'm not typically outspoken. If you go to phy.supplyframe.com, you'll actually see there's a bunch of stuff in there. I just did a write-up on Nordics 51822, the actual little beacon boards. I got some of those back. I'm actually doing a teardown right now on a TIVA development kit. A lot of those are starting to get more detailed, like the TIVA thing will actually have the process of bringing that up and actually getting it working and what's the sort of internals of the micro and what's on the board and all of those other sorts of things. So there's some detailed kind of technical stuff that's useful for engineers. The sorts of things that I think about when I actually get a development kit and I plug it in and like, hey, what do I care about? And what are the things that are on the board and what's valuable and what's not and what's stupid and should I have spent money on this or shouldn't I have? All of those sorts of things. So I'm trying to answer some of those questions. And then there's some other stuff which is really driven by the data that we have. You know, we do a lot of, SupplyFrame does vertical search for electronics, and we're doing a lot of stuff with the data actually looking at like what are the top component searches that people are actually searching on, that sort of thing. So I'm actually doing some interesting stuff there and trying to do write-ups of the sort of interesting items within that data and what components people are searching on, what they're buying, that sort of thing. Not necessarily to influence behaviors, but it just sort of captures what's actually happening in the market. So there's some, read it and tell me what you think. I'll be curious to hear what you think. Last thing, I run a workshop in San Francisco, probably not for most of this crowd, but the workshop is actually run here. It's running again on Saturday. Please don't crash because it's totally full. But the workshop is on designing circuits. So I take people through the actual process of designing truly manufacturable circuit boards. The thing that I found, you go through the engineering curriculum, you get to the end of it, you've done a lot of circuit analysis, but nobody ever taught you like what the pad size should be, or what the track width should be, or why we actually care about those things, or the reactive elements of the circuit board, because the circuit board is never really sort of factored into the overall circuit equation. So I look at lots of things, sort of reactive aspects of circuits, inductance of vias, inductance of tracks, capacitive effect of tracks over planes and over split planes and all of those other sorts of things. So there's some of that detail. But then there's all the other just sort of practical know-how shit, like how big should my decoupling capacitors be? And what should my track width be, or how big should my pad size be? Sort of thing. So that workshop's actually running on Saturday, but it's totally free to the public. I run it from 10 a.m. to 7 p.m. usually on Saturdays. It's not all the time. It's sort of at will, meaning my will. But if you're interested, by all means, jump up onto the meetup site. If you just look for like PCB workshop, something like that, you'll find it there. It's also going to be run at SolidCon this year too. So if anybody's interested in you're going to SolidCon, it's actually going to run at SolidCon, which is down in, where at SolidCon? Fort Mason. which is down in Fort Mason. It's run by O'Reilly. So if you're interested, by all means, let me know. Before we get started, we've got some stuff to give away tonight. So if you stick around towards the end, I'm going to give these away seemingly at random. We were kind enough to have them donated, so we'll be kind enough to give them away. Other than that, I don't know that there's a lot more in terms of detail there. We've got 2 people actually speaking tonight. One of which I still haven't gotten my logic analyzer yet. But...
Well, we can fix this right now. Which one did you order?
I ordered the 16 gentleman. I went big.
No, you don't have it?
Not yet. Not yet. It's okay. That's not your fault. That's because I ordered it like 2 days.
No, that's like a 1 to 2 week day.
Yeah. So I've got to give you some time to actually put a label. I know it's coming.
Hey, actually, we got pictures. Well, actually, you're not going to want to hear about my presentation.
Okay. Fair enough. Fair enough. As long as it's not about how I just ordered the wrong product, then I think I'll be okay.
No, it's not how your product entered the world.
Oh, cool. I'm actually. Yeah, I don't know. We'll find out. I'll reserve judgment. Chris, did you want to come up? Yeah, sorry. There were a couple of other people that wanted to present first. So before these guys pop up, I wanted to give other folks. Where's Andy? There you are. Do you want to come up and just give a quick couple of minutes on the stuff that you're actually that you've got back there? This is really cool. I saw when he came in, showed it off to me, and asked whether or not he could show it, and I'm super excited about it. But I'm kind of
it is a cool thing.
And this is more than
So there's 2 minutes per. Back in the mic.
yeah.
I don't even think I have 2 minutes of stuff to say.
Oh, come on, you want to do that?
Hello.
My name is Andy Turk. I work for Avignon Corporation, and we are building this thing, which is the Avignon Collector. Okay? That is somebody. Maybe I can just speak loudly so I can use both hands. This thing looks like a pair of headphones. You can actually wear it like so. And you can also plug it down into video mode. And
Nice.
there are 2 720p HD projectors in there that actually form images on your retinas.
No way.
It's battery powered. You can watch movies on it. You can listen to music. It's way cool. And we are deep in the middle of building this thing. This is one of the first prototypes that actually looks the way that it is going to end up looking. This one unfortunately doesn't work because it has a problem on the USB line that has to be fixed, and then it would actually light up and do things. But I just kind of wanted to wave it around, see if there was interest in the crowd for coming back possibly with some of our hardware folks. I'm the firmware guy, so I write all the code that goes in this thing, but there are some hardware folks that have lots of interesting things to say as well. So, interest?
Yeah.
I'll take that back to the team and see if we can rustle something up.
So you can just project on the retina?
Yeah, so the technology that's used in here is called a DMD device from TI. There are these little MEMS mirrors, micro mirrors, 1 per pixel. We have color LEDs on each eye that send just kind of a beam of light through, and all those little mirrors are either reflected into your eye or reflected somewhere else. And they're modulated, and that's how we do RGB, 1 per pixel. And it's all stacked in here. There's 4 PCBs up here in front of your eyes. There's 1 in each ear can. There's some crazy micro coax cables going background. You can probably see some of those in there. It's just amazing technology. There's freaky optics in here. There's really hard electrical stuff to get it done. And the mechanical challenges are really huge. I mean, this thing is creaky, and we have to get rid of the creakiness. I'm not responsible for doing that. Firmware doesn't creak, fortunately. But it's a fascinating project. And, I think we'd like to tell you more about it.
So does 1 mirror pixel do only 1 color, or does it alternately do red?
No, it's just like a pixel on a an LCD screen or something like that.
Well, because some use a color wheel and some.
So this effectively uses a color wheel, but the wheel is actually a color LED.
So you have different color LEDs and a color wheel that directs.
It's PWA. Yeah.
Obviously not a real wheel spinning in there, and then so how many frames per second are you running?
Hey guys, let's keep going.
Okay. Yeah, I guess. Yeah.
Okay.
probably over 2 minutes. There's lots of stuff to talk
that'd be
about.
great for us.
I'll see if we can come back with actual presentation and get some of the other hard.
Yeah, that would be totally awesome. That'd be totally awesome.
Thank you very much.
We'll make sure. So I'm not sure if anybody else is interested in talking before we get started. Okay, cool. Chris, did you want to introduce folks tonight?
Oh, cool.
For those people who have come before, you'll notice the advent of a lav mic. I bought that myself.
I did lobby pretty hard for that. I'm going to take some credit.
Thank you, thank you. Except I did buy it myself.
I did read one more.
Oh yeah, sorry. No, we have to. No, sorry.
Cool. So this is Mark from Saleae. They make a great logic analyzer. If you haven't tried it, you definitely should. I think he brought some that he'll be showing off and demoing as well. They just released the Logic Pro, and Mark's going to be talking about some of the challenges, quote unquote, that they went through and how they worked through them and some of the fun stuff with that. So give it up for Mark.
See how Windows handles this. Oh, perfect. Okay. Perfect. So I actually forgot to bring a logic analyzer with me, but fortunately one of my friends is coming and I know he had one, so I called him up on the way over and I said, hey, can you bring this? And so thanks, Alex. Unfortunately, you guys won't get to see the inside of it in person because we don't think we have the right torque screwdriver to take this apart. But yeah, so my name is Mark Garrison, and I have a startup with my brother called Saleae. We've been doing it since 2008, and we build logic analyzers. And a logic analyzer is a debugging tool for any kind of embedded project. If you're working on microcontrollers or FPGAs or anything else that's got digital logic in it in pretty much any form. And the way it works is it's kind of like an oscilloscope, and I'm hoping most of you guys have used that, if not all of you, where you hook up a probe or a collection of probes, in this case, to the different signals you want to look at. And instead of recording analog waveforms or displaying those to you in real time, it records pure digital data over long periods of time, then allows you to view all that data on the computer. But it does so at a very high sample rate, so you get a really good bandwidth. In fact, this product can sample up to about 500 megasample per second, which is 100 megahertz bandwidth. So any kind of any microcontroller you're working on operates much slower than that. So a lot of applications include stuff like let's say you just got some new parts from like Adafruit or something. You got your Arduino, you got some new sensors. You hook it up and then you record. And you start to write that code for the first time and record all that kind of communication. It shows you on the screen, and if you're like me, you become sort of dependent on seeing that. So when you start writing your code, you don't really rather than sort of running test benches or trying to figure out what's wrong with it, you just look at it instead, and hopefully it saves you a lot of time in the process. But what I'd actually like to talk about tonight is the Logic Pro that Chris mentioned is part of our new product line, which we launched late last year. And it took a really long time to sort of bring that out in the world, and the problems weren't over once it started shipping. And so I'd love to talk a lot about sort of how to bring a product to market and what can go wrong in terms of manufacturing and stuff like that. But before we begin, I want to ask a couple of questions just to get the show of hands to see what you guys have already done or already know, so we can sort of skip over those sections. And I should say that if you guys answer these questions wrong, I will have to come up with something completely new to talk about. But just to start out with, who here has heard of or used actually, who's heard of the Logic Analyzer before? Oh, thank God. All right, who here's used the Logic Analyzer before? So, and then my favorite question, who here's used a Saleae, or if you don't know, it's a Saleae? Okay, perfect. All right. So all 11 of you guys, extra points. Thank you very much. Ooh, awesome. So there's a guy on Twitter who built like a condo to hold all his logic analyzers on a 3D printer. So you might want to look into that if you get another one, just to keep them organized. But they're pretty small. But the rest of you guys, you have some homework to do. But actually, I have a few more questions though. First of all, who here has soldered together a circuit board before, like a printed circuit board? Yes, excellent. Who here has done like surface mount components? Good. All right, because that's what this talk is about. This talk is about like what happens if you wanted to manufacture at scale an electronic product that had surface-bound components, but you wanted to do it yourself. And I don't mean like with a soldering iron and like an infinity time. All right, so I should start at the beginning of the story. And in a lot of the story, my brother is my co-founder, and a lot of the story is his too. But basically, we launched the first product, Logic 8. Logic. The naming convention is very confusing. Back in 2008. And when we launched this is the very first product that either one of us had ever brought to market. And we had tried a lot of different other ideas before, some pure software projects all over the map. And we had no idea how to manufacture it. We were also both from Arizona. We had no idea what Silicon Valley was like. We had no idea what VC was. The idea of like getting help was like this dream that we had no idea how to actually begin. So we sort of did the whole thing ourselves, like in this bubble, which is not the right way to do it. I recommend, like, you guys are already in the right city. Like the first thing, if you want to build your own product, the first thing you should do is ask other people. And so Joe actually hand soldered first, probably over 100 units we shipped. And it's one of these things where once you start, you can't stop. Because you stencil out all these circuit boards, right? And then you're like, okay, once the solder paste is out there and sitting on these circuit boards, and then by the way, if you guys haven't used a stencil before, instead of using a soldering iron and actual wire solder, instead use this stuff that's liquid at room temperature the first time at least, and then and you have this literally a stencil, like a spray paint stencil. You put it down on the circuit board and it just has holes in it over all the contact pads with desolder, and then you just squeegee. Literally, it's called squeegee. You put the solder through the holes, and then you put the whole thing off, and you don't want to bump it when you lift it off, otherwise the solder's all screwed up. And then you put all the chips on, and then you either bake it, most likely in a toaster oven, or you can hit it with a hot air gun, whichever method is easier for you. And so I think we did the first 100 like that. And that was really good pressure to figure out how to not have to do it anymore, because we started out selling like 1 week maybe, you know. Like I remember the first guy Chip bought one off of eBay, and that was sort of like a huge deal, but that's just one, and there's like 25 parts on the board back then. So it's like, oh, no problem. That takes like less than no time at all to assemble. But it quickly scaled up to this point where you're shipping more than one a day, and now you got to build these big batches. And so once you lay out that solder paste, you got to stay up all night long assembling these things, right? So the first thing you got to do is figure out how to have somebody else assemble it for you. And so, wait for that 1 second. But so the first thing. I can't remember the name of the first company we ended up working with, but we ended up outsourcing the PCB assembly and basically just sort of turning the operation. And one of the things the most important part of that, by the way, is managing the circuit board components. But if you guys want to talk about that, I can talk about it afterwards, because that's boring. Although it's also very, very important. In fact, it's probably the most important part. But the actual getting the parts on the board is sort of where I'm going. So we outsourced the assembly for the first products. We did it in China for a while, and we moved between different vendors in China, and we had all kinds of problems. When you're operating on when doing a build quantity of like 500 units at a time, it's hard to find really professional players to work with. So you end up using either people who they're very new companies, and so they don't have big vendors yet. So they're still looking for smaller players to sort of like. So they get up to capacity, and then once they're at capacity, they start only taking on larger and larger orders. And those ones you want is more volumes. And then your other alternative is companies just suck so bad that they can't get big orders. And they just like, oh, we got all kinds of problems with those guys. And so we ended up bringing manufacturing back into the US, but that's where our first two products, Logic and Logic 16. When we launched these new products, we did the assembly of the first batch in the United States to this company actually in Fremont called Smartron. And if you're doing any kind of small volume, short term, have you guys used them? Yeah. Oh, fantastic. I really like working with those guys. But assembly in the United States is expensive. Like in terms of price, and I don't know if this is on the order of about 5 to 6 cents to put a part on the circuit board, which seems cheap. And it was cheap for the first two products. Logic had I think at the end of its life, it had 40 parts on the board. We added some stuff. Mostly we enhanced the overall protection. Then Logic 16 had over 100 parts. And so at 6 cents at 100 is like $6, right? But this guy has 924 components. 600 and I'm not exactly sure how many are 0201 components. Now, that, by the way, the decision to go to 0201 is made by a hardware designer, not by a manufacturer. And the motivations are complete opposites between the motivations are completely opposite between like the guy who's designing the circuit board and the guy who's building the circuit board. The guy who's building the circuit board is like, let's just use tech from the 80s because it just works great and it's cheap and it's fast. And the guy who's designing it is like, let's use the latest and greatest. Let's use laser cut vias because no drill bit is fitted up to cut that via into that VGA. Like this is going to be great. We're going to do like 4 mil space trace circuit board manufacturing. And so that we'll get more on that later if we have time to get to it. But basically, the idea is that at one point we had this vision. Whoa, this way. Yeah, we might need to, but so that we had this vision of like instead of like slogging our way through finding like a high quality manufacturer that could build a board with 900 parts on it, but do it for an affordable price and quickly with a very, very high yield. Like we wanted instead to like just do it ourselves, and this is sort of the beginning of that story. And so the first step to do that is to use a machine called a pick and place, which is just a robotic arm. Looks a lot like a 3D printer, except way faster. And it just picks up parts and puts them on circuit boards, right? And then you need 2 other things in order to complete the process. The first thing you need is the stencil printer, and that's a tool. And this, by the way, is a manual. Thanks.
So the higher the feedback, less you just flip it. You're as close to your throat as you can. Then
Test.
automatically
Is that good? Test. Okay. So that sounds a lot better. I think my headache's going away. But
right in here, you're really rocking. Like right
I swallow it. I have no idea how we're doing on time. But
It was on your t-shirt.
all right, let's do this.
There you go. Now you're
Sweet.
talking. Now you
Test. Okay. So anyway, so we bought this pick and place machine. And we bought a stencil printer, a manual stencil printer, which means it's not completely automated, but it's still really, really easy to use. And we bought a special type of reflow oven called a vapor phase reflow oven. And that's a really exciting piece of technology, which I won't talk about at all tonight. Here I'm talking, and I don't have a great picture of this machine because I kind of just found some photos from my old phone and from my camera that I took at the warehouse where we're doing this, and in about 20 minutes before I took off the drive here. But let's just start with this photo. So this is my brother Joe. He's the CEO of Saleae, and he's on one side of this pick and place machine, and I'm on the other taking this photo. And just to cover some stuff, this is the head, and it's a lot like a 3D printer head, except it has just sort of like this little thing that goes down, and it's got a vacuum. It's actually got removable nozzles. It's kind of like a CNC mill, and that has tool chains, and it's got this collection of different nozzles. And those are located back here in the back, and that's for picking up different sizes of components. But the idea is to use vacuum to pick up a part. And then these things right here, which are really cool, they're called feeders. And a feeder is the idea is you take a reel with parts on it, but someone has to take the tape off of that part, and so that the machine can pick it up and so advance the feeder. And by the way, this stuff is like ridiculously exciting. If you like anything mechanical, watching our videos of this machine, and I think it's cool. I hope you guys think it's cool too. But each one of these feeders is like this cartridge. You can pull it in and out of the machine. It's got all kinds of electronics in it. It's like ID chips and all kinds of stuff. You can track the number of parts that are in the reel, all programmable. It's got this little black reel up on the top, and that holds all the tape as it slowly pulls the tape off of the reels, which are down here. And then there's this little tiny. It's like 4 millimeters by 4 millimeters of exposed area that is where the chip sits, or the resistor sits, or whatever component is in the reel. And there's different sizes of reels. Most of the large reels are behind Joe. They're based on the tape width, and so we have like ADCs, which are like about 8 millimeters by 8 millimeters square. Then we get parts that comes in tubes. If you're doing manufacturing, don't buy parts that comes in tubes. It's the jankiest thing ever. It'll just on a vibration table. The parts sort of like trickle out, and the machine tries to pick them up. It doesn't work half the time. And you spend the rest of your life tuning it. And so if you have to choose between a tube and a reel, just get the reel. Ninja reel's great. They'll literally like give you a reel with just the right number of parts on it. You don't need the whole reel or anything. and then add that inventory bonding. Like inventory bonding will like give you like a partial reel of anything. You don't have to pay for it until it arrives, like 3 days after it arrives, which is great. But then in here we have trays. All the big chips come in trays, or most of the time at least, since we have FPGAs, which I can talk about for like an hour if anybody wants to hear that. But and then back here we have the USB 3.0 chips, which are Cypress FX3s. Really cool chips too, all high-speed stuff. And then in here we have the circuit board, where the panel. This panel has only 4 boards per panel, and these are double-sided boards. We're just no time to use that either. But, and so this machine, in theory, once you loaded all the feeders into it, you got all the reels on the feeders, puts those things on those, pulls the parts off and puts them on that circuit board to the tune of 5,000 parts per hour. Not that we've ever run it past about 2,200 parts per hour, but yeah, there's no time for talking about that either. So I did want to briefly discuss, so the first batch we did was,
So you mentioned two-sided boards. You didn't have to
so when I say two-sided, I mean there's components on 2 sides.
Oh,
That is a 12, or the picture I had up, that board is 12 layers. Yeah, control the PVC. Good times. Man, I don't think Ultimate's installed in this, but otherwise I'd love to show you. But I just wanted to mention, before we bought the take-a-place machine, we did the first batch with Sparktron Electronics. Did a tune of, I want to say, $60 per Pro 16, which is the reason that we wanted to not pay that much. And the worst part is we made, like, one thing nobody ever talks about is the feeling when you're launching hardware products and you're doing your first production run. The feeling that you know that if anything goes wrong at all on your production run, it's like, oh my God, it can be terrible. Like the worst case scenario is it kind of works. You ship it to customers, you think it's working, and then you find out after you ship like 500 cups, like you have to recall them. That's the worst case scenario. That's like everyone's fear, and they go to sleep. And the worst part is that nightmare doesn't end until a couple months after you start shipping, and you're like, oh, thank God, this ship works great. 99% of the time. Or in this case, like 97% of the time. But that's the first run, so it's still pretty good. Anyway, we did have one design problem. Fortunately, we caught it early on. It was only 1 of 4 products. And I have a picture of what my brother's doing here. We ended up, people say rework's expensive, rework is scary. Rework is a lot less scary after you do it. And we did a lot of it. There's this one component, actually, there might be another photo just hiding, but the only thing I have a photo of is the manufacturing problem. So as I was saying, the circuit boards were designed by a board designer, in this case Joe, who's really excited about pushing the limits. And so this part is, the part that was on here before we took it off, is a load switch. All this is basically a transistor with some other fun stuff, and it's used to turn on and off power to a subset of your design so you can conserve power. In this case, when the USB's got these states where it wants to save power, not save power. We didn't implement it. Not yet, but hey, it's updatable. And so this load switch, this thing's tiny. It's like 760, I love using microns. It's 760 microns by 760 microns, or 0.7 something millimeters square, right? And so, and it's a VGA part. And there's a recommended LAN pattern in the data sheet, and tells you exactly in the solder mask, which is the green stuff, tells you exactly how close the solder mask should get to the copper copper pad, right? And without getting into too much of the detail, somebody else, some other manufacturer is like, oh no, you shouldn't use that. You should use this other dimension. And so we bought anyway. What ended up happening is we brought the solder mask, which is this thick green stuff on top of your circuit board. We brought it a little bit too close to the pads, and so the balls of solder wouldn't connect on something on the order of 20, almost 30% of the units. And this is when I discovered that X-ray inspection for VGAs is bullshit. X-ray inspection for VGAs is great at detecting a couple different types of problems, like cracks, all kinds of stuff, right? But when the ball of solder doesn't fully contact the pad underneath it, you can't see that on really nice X-ray inspection. And so we quoted rework with a bunch of different people, but we ended up developing a process in-house where we could do this in less than 10 minutes of work. So we just did it. And so this is a photo of Joe. Joe, because he has by far the most service mount experience in the company, there's just 9 of us total. And he did this particular stage because it was I try to do it, and it takes me like 40 minutes to board. So, and I'm decent at surface mount work, but he would pull the chip off, scrape up the solder mask all the way around it, and then like deposit using like an X-Acto knife, like a liquid solder paste, on these tiny BGA things that are like, I don't remember the pitch was like probably half a millimeter, like, and keep them separated so it didn't short out. Put a new chip on it and like hit it with a hot air gun, and you could do like do that all in one board in 10 minutes. And I was on the other end of this process, figuring out exactly which low switches are bad, feeding him boards, and then taking the boards he reworked into verifying the low switches were working properly in both states. By the way, we had this very comprehensive like QA test before we ship a board, so like I'm very confident in the quality of work we did on that. So anyway, that was the first batch of Pro 16s, and so we bought this pick and place machine. It was heavily delayed, so we got it after our first Pro 16 batch, and it was right around the like we made a couple of bad decisions, which we detailed in lots and lots of detail actually on the amp hour. So if you're really curious about and to a smaller degree on our blog. So if you're kind of curious about sort of what we did wrong in this situation from like a company, like how to run a company standpoint, you can find all that information here. I'm just gonna stick to the technical stuff because that's like what I think is the most interesting. So we get this pick and place machine, we start working on it, we program into the board designs for Pro 16, we do a whole bunch of calibration and testing and whatnot. We're printing circuit boards and stuff, and let's just watch a video of that in action because too much talking. Also, let's move this because the audience. So this thing is running at about I think 40% speed right now. The top with the panel open so I can videotape it, and also apparently I can't pull the camera still. But so this is a dual head machine. And so what you're seeing here is these two little vacuum heads, and those are O201. Let's turn on the repeat actually, because I want to talk about that more. This thing on the side is a red herring. It's just a syringe. It's used for dispensing. We don't use any dispensing. These guys right here, the two vacuum heads, they're super cool. Every time they go into when they go all the way back up, this little panel swipes underneath them. It's got some mirrors on it. So there's a camera inside there. It looks at the mirrors and looks at the part. Photo recognizes it. You have to build an image library for every single component, with the exception of a few that are like built in. Most of the O201 components you didn't have to train manually, but there's a whole bunch of non-O201 components on the board, or non-passive components on the board we had to tune manually. And so this is it in action in one other scene here. If there's anything in particular you guys want to know more about, I'd be more than happy to answer like little questions on the way. But
Are you running Windows on a Mac?
yes, I am. And don't worry, it's who booted, but we build cross-platform software, so we have to, and this is one of the only computers we have with an Intel 8 series host controller, so testing on Windows is very useful. But
did you buy the pick and place new or used?
we have a lease for it, and it's new. And this machine is rated for O201 components, and it's supposed to have a hold accuracy of it's supposed to have a placement accuracy of 30 microns at 3 sig, or I think 6 sigma? I'm not sure, but it's supposed to be extremely accurate.
And does it come with a technician whenever it doesn't work, or do you have to?
Yeah, so I think part of the lease included the first like 20 hours or something like that, or first 40 hours of technician, and then after that it's something on the order of $1,000 a day, which for the amount of money you're saving over like paying 6 cents a part is like, who cares? There's just so much money left over, assuming it worked properly, which it didn't. We'll get into that later.
And then,
by the way, we're not using like. It's a tragedy. It's literally such a tragedy where it's just like you just open the bottle and you're just drinking everything you have in sight. It's like, what the hell's wrong with this machine? We put like hundreds of our own hours into it, like giving up sleeping. My first 100-hour work week was working on this machine, followed by my second 100-hour work week. But so let me show you some photos of what can go wrong. Well, maybe we'll look at some more photos of the machine first, because those are depressing. So Logic Pro 16 has about 82, 84 unique components on it. And so, and between all 4 of the circuit boards, there's a grand total of, well, actually it's about 130 unique components total. Our filing system ended up going to 150 because there are some components we like phased out early on. But the most important thing you do when you do this yourself is do not accidentally put that reel into that slot. The worst ones are these white ones because they don't look the same. If that's 64, when that's 63, you start production, it's like game over. Good luck figuring that one out. Fortunately, every time we pull a panel out of the machine, the very freaking first thing we do while the machine's working on the next one is break that thing apart and we do a full automated test on it. And it's not like a power on to make sure the current and the rails look good. It's like we capture like complex waveforms and then we do we calculate the effective number of bits for every single device we ship and we make sure that it fits within parameters. We look at INL and DNL, which is integral nonlinearity and differential nonlinearity, I think.
Yes.
Thank you. I've had a couple of beers. And then we do a bunch of other stuff on each individual board, and there's all kinds into this massive MATLAB stack and this massive G-SARC stack. And so when we ship these things, they're fully calibrated, and we know for sure they're good. And there's more we could do to weed out infant mortality, which we want to work on later. We don't do any kind of temperature cycling. We don't do extended burn-in. The test is a little bit slow for these products, and so they do kind of get like some little built-in burn-in time. But it'd be nice if we shipped everything with 24-hour burn-in, and a temperature cycle would be even better. But those are sort of things you don't need to add until you get sort of some statistics back and see like, okay, like what's our return rate looking? What's our DOA rate looking like? And they're actually very, very low, which is astonishing considering the part count went up 9x over the last product we shipped. But so this is some more shots of the pick and place machine. Let's see. So this is Pro 16 bolted into it. Pro 16 only has parts on one side, and because it's such a much larger product, we were able to get away with only 8 layers. And so there were some bugs in the software of the machine that prevented it from doing panelization properly. They sent us updates like 2 months in or something. We didn't do due diligence properly on this machine, which is sort of like. I'm not going to say it on video. They were not happy with it the last time I did that. So well, that's a completely separate story. But overall, like I think they did an outstanding job of addressing the issues we had. There's more photos of the feeders. They're really fun to play with. And then those are the reels attached to the feeders. These 2 positions, other than being convenient for like accessing reels, when you have a larger reel, you have to use this upper mode. And we have some like reels that are like I think 300 millimeters versus these ones which are I want to say 100 millimeters, but I don't really know.
You have to switch out the reels a lot, the feeders, if you have a dedicated feeder.
I'm so glad you asked. So we did not have enough feeders for all 4 of our different SKUs. Now, Pro 8 and Pro 16 are not, there's only 4 components to vary. And so we have enough feeders to cover those. The difference between the 2 Pro models, we have 4 products, Logic 4, Logic 8, Logic Pro 8, and Logic Pro 16. The 2 Pro devices are almost identical, except one's double the channels. Logic 8, about 55% of the parts are the same, but we don't have enough feeders. These feeders are like $1,000 each. So it's not something we stock. And so we actually have to manually switch the machine over to change product lines, but it would be faster to switch between the different types of products if you had more feeders. And then Logic 4 has a very, very small part count. That's, I think it's 150 parts, I'm not totally sure though. The cool thing is the software optimizes where the feeders go find these things. And so the parts that are used the most are these ones, like right here. They're the closest geographically to the circuit board, and so those are the ones where we have one component that, like, I think it's a 0.1 microfarad capacitor, where we have like 120 of them per board, and so it's like sitting right there, and then they're spaced perfectly with these ones. The most common one is not next to the second most common one. Is not next to it. It's like 4 feeders down, but it can plunge both heads simultaneously. They're perfectly offset from each other. Pick them up and then go to the board, drop one and drop the other. And then the way it optimizes placement is it literally will drop one on one side of the board and it'll try to drop the other one as close to the other existing location, so it doesn't have to drive the header out as much. That's where you waste all your time. That's part of the vision system. There's like four different like main vision cameras on it.
So it's working off fiducials on your board or something?
Yeah, so there's two fiducials on the board, opposite corners from each other. The board actually has more than that, but this is only what the software uses, and it uses that to like locate it. Once it's located, it doesn't have to look at them again until it's done. But when you have problems with pick and place, you end up with a ton of photos that look like this. This is under a microscope, like holding the camera on it, which I'm also developed as a skill now. But if you look closely, this has not been reflowed yet. So this is like what solder base looks like before you cook it. And all the components are sort of just sitting on top of it. And so a lot of these defect photos, just looking at this thing in general, like quickly looking at it, you can see a couple of parts that are not placed too clearly. I was just looking 1 second ago. This resistor sort of like hanging out to the side. This generally doesn't result in a defect if the part's hanging down here. It usually just gets sucked in there by like surface tension when you recook the board. You have components like this, where this resistor is pulled too far on one pad, and it's just barely touching the solder on this pad. This probably has about a 10% chance of tombstoning, which I'm going to show you some photos of later, which are pretty depressing. That one looks really bad too. That was off the side, it's going to be okay. The paste is a little bit thick on that one. And when chips are off, this is perfectly fine. Like this chip's just going to get sucked right into position, so nothing to worry about.
Is it bent leg lower right corner?
Which chip?
Lower right corner.
Oh, this guy, yeah, that's totally crumpled up. Generally, that's like something that minor would probably be fine. And if you have any kind of problem there at all, the functional check picks it out. Like it's incredible kind of like manufacturing defects you can pick up when you're like analyzing analog data up to 10 megahertz of bandwidth. Anyway, this is let's see, is this one have the missing parts? This is the BGA placement. We never had a BGA placement problem ever. And the vision recognizes the pins on the bottom of the board and places it down, and like they just work. And it's not a super high density chip, but it's pretty decent. And then this was just I think 0201 components only placed, but zoomed in farther. And so you can see there's actually two problems. In this particular one, the solder paste is offset on two axes, like both axes actually, by I think 5 microns. Which isn't a problem until you get to this guy. This is an obvious problem because the solder paste is offset and the part is offset in the other direction. The amount of connection you have here is minimal. That thing's in tombstone, almost guaranteed. Here's a picture of a tombstone part. This is an extremely minor tombstone. This is after oven tuning, so it goes extremely slowly to the liquidous state. And so the surface tension doesn't build up as quickly, but it's still built up fast enough for like a poorly placed part to tombstone like this. And so what you're actually seeing is something like, it's also called drawbridging, where a component's supposed to sit on both sides, and it's sort of like this side sort of melts faster, and gets sucked over here, and then the surface tension on the much lighter weight, small parts like this, pulls it up like this. And it's kind of like a drawbridge. And it's also the worst thing in the world to look at under a microscope on or you build. So you're like, oh, I feel terrible. You count them, and it's just, and sometimes the counts are ridiculous, especially if your oven's not tuned properly, like 100 tombstone parts. And you're like, oh. This is a more serious, this is a more common tombstone where it gets pulled all the way up to like a full 90 degrees, and so you can see it's not like, and that's the easiest one to see. There's another one, and there's a couple more. There's just one in that photo. Just this guy, obviously, and the rest of it looks fine. And then there's one. There, we looking around yet? Not yet. There's two, at least. There's at least two tubes in the picture. Okay, cool. What else do we got? I think that's most of the photos we have, but or most of the photos are probably we don't have 20 minutes to put us together. So yeah, I think that's probably time. I'm probably past time by now. But if anyone has any questions, any quick questions, I can take them now. Otherwise, you can ask me later.
Is this lead free?
Yeah, everything's lead free. We ship to the EU with CE certified.
Right. Okay.
Lead free changes the melting point of solder from about 160 degrees Celsius to about 230 degrees Celsius. And in the oven, we use boils this liquid called Galactic, which boils at exactly 200 degrees Celsius. It's actually kind of magical in that way. Like you bring the whole oven up to that temperature, and it's like it doesn't boil at all, and then you bring it like 1 degree higher, and it starts boiling like crazy, and it fills the oven with this vapor. which then condenses onto your circuit board, and it actually thermally conducts very, very efficiently, actually, from the boiling liquid through the vapor, like the extremely high humidity air, to the vapor that's like built up on your circuit board, and it heats up your circuit board until your circuit, like every single component, everywhere, your entire board is at 230 degrees Celsius.
So is it only on the bottom because you have a two-sided board or something? Or?
So so when you have to do double-sided boards, there's a couple different ways you can do it. Turns out that once you reflow a board, it will not melt as easily. And so if you use the same solder, by the way, one solution is these two different types of solder with different melting points. But if you use the same solder and you just flip the board over, the parts on the bottom will not fall off. And there's other solutions where you actually put, like, you just use the dispenser on there to glue some parts down that are more likely to fall off. All of your passives won't fall off, your VGAs won't fall off because you have a ton of solder points on them. There are some components you have to worry about them sort of like hanging down or completely falling off the board. Those ones you'd want to glue down like chips and stuff. But you've never actually had any problems with that. Yeah.
So you outlined the sophistication here, which is great. So these Kickstarter pick-and-place machines, is there any hope that they'd be useful at all?
So a great question. There's this tripping point where it goes between where manual work, where you can't really do it manually anymore, you can't really do manufacturing, and so having like one of these like cool vision assisted or maybe no vision pick and place machines that assist you comes into play. One thing people I think underestimate the most is the amount of work it takes to get like cut tape parts. So you get a big bag from DigiKey of cut tape, like peeling back like when you buy one of these, like pretty much any machine to peel back the tape, that takes about 4 times longer than assembling a board. So if you wanted to, I think the trimming point is right around 10 boards, or basically 1,000 placements. I'd be willing to do up to 1,000 placements, either 1,000 on one board or 100 on 10 boards by hand with tweezers, before I wanted to use a machine where I had to actually peel back all the tapes and mount them and program it and then visually learn all the components. They're not already visually learned. Or if it's a manual placement machine, you can skip those steps. And so I'd probably switch to a manual machine around 500 parts or something like that. But I'm pretty good at doing it by hand. We have this boat project, which I talked about on the Alicia White Stuff podcast, and it's also on our blog, where we ended up assembling a ton of components by hand. And I think there's just no way a pick and place machine would be faster than that. The amount of time it takes to set up a pick and place machine with like 80 components in it on reels or even tape, it's like half a day. And so if you can do it in less than half a day, I wouldn't use a machine. I have some thoughts on how to speed that up if anyone wants to start a pick and place company. Also, no skills on that, but yes.
Did you try different size pads?
So one of the things I wish we had time to do is different boards and then try that. But the problem was, even if we could spin different pads to test with, there's beautiful documents on the internet where they test all kinds of different pad geometries and see how they affected tombstoning and other defect rates, including different geometries where you like make this little chevron symbol with the pads, and that changes the way the surface tension works, and it won't hold up as effectively. We didn't do that mostly because even though we could spin prototypes, the amount of money and time it would take to like dump the entire board set and then build a new board set was intense, and we didn't think it was going to take as long. We didn't think the problems we had were that serious. We didn't think they were going to require that kind of like forethought. We were like, oh, we're going to get this thing figured out in like a week or a couple of days or something like that. Any other questions?
How many tombstones on a board defects before you throw away the board and just do it over? Or
we're really fast at fixing tombstones, but
you have like 30 on there, but you still try to fix it.
30 tombstones? Yeah, for sure. I mean, you can fix 30 tombstones in 5 minutes. Any other questions?
Is there a reason why you did not mask off the base?
Oh, they're fully tinted. Yeah, they might not show up because the solder is kind of clearish, but the vias are fully tinted. Except for 4 of them on the back, which we use for signal integrity testing on the clock lines a couple of times. Yeah.
How the money worked out? So you said it was 6 cents to place each part.
Yeah, so for Pro 16, it's like $60 a board, and the original sale price is $4.99. Like basically, like of all gross revenue, 10% of it was going to support from. And you're like, oh man, that's a lot of money. We want that money. That's what heavily motivated this process. But now we're turnkey building this thing in Taiwan, so at least we will be in a couple months.
How much did it cost for placement?
Well, our original spreadsheet expectations put it around 2 cents a placement, but realistically, with all the overtime we were paying everyone who's helping out with it, and the much slower than expected assembly, like we were on the order of probably a little bit more than 6 cents replacement. So we didn't lose a lot of money. What we lost with this thing is we went out of stock for a really long time. We failed to meet our customers' expectations. We really fucked up Christmas for a lot of people who were like, I ordered this thing as a Christmas gift for somebody. That's like the worst thing in the world if you're like, I screwed up Christmas for somebody.
You lost time.
And
You lost time.
yeah, exactly. And in time, and during a period where we didn't, we can talk about the backup options later, but we did not plan this properly whatsoever. But anything else? Yeah.
Yeah, that startup.
Which one? Okay, cool. We had a booth next to you guys at Maker Fair. Yeah, when you have, let me know when you guys have figured out the tape peeling back problem. Yeah, my thought. So my thought was if you just built a factory right next to DigiKey. And then, by the way, ask me about this later. But build a factory next to DigiKey so you get the same day deliveries, and then build like a tray basically that just has a holder for tape. And then like program, more importantly, do vision libraries on every single component. When you put like every time somebody orders something, buy the tape from DigiKey, do vision libraries on the small subset of the components, mount them into a panel, and then send them to somebody who's got their like $3,000 or $1,000 Kickstarter pick and place machine, right? But now instead of doing anything at all, they just take a ESD bag off of this tray, mount it into their machine, download the library that came with it, which has coordinate data and has vision libraries, and then just pull back all the tape at once, hit the go button, and sit back. And I think that might be a little bit more scalable. Like dumping the components in, we have 600 different, we have like 40 of these components are 0201. You can't tell those apart. We have like 12 picofarad capacitors and like 11 picofarad capacitors. And we probably have 11.4 picofarad capacitor in there. Like they're not marks. But I can't wait to hear about them. So. All right. I'm probably way past time. But anything else? Sweet. All right. Thanks. Oh yeah. Oh, for sure. It's Alex's. I'm sure he won't mind. He's there. Me too. Sweet. If you guys want to check this thing out, it's kind of cool from the outside. It's cooler on the inside, but I like the closer. Alex, if you go yeah. Put it. I know that. The old price I agree. Yeah, no, we have not pro. Oh, yeah. So you mentioned the one on the price.
Yeah, no, that up.
The original one and then it's right now. Yeah. And I swear to God, that was like religious. That's religious. Yeah, it's not an engineering thing, it's religion. Yeah. And I really wish we were in the middle of it.
It should be loading up, looks like. Oh wait, I have to switch here, sorry. Oh, sorry. I was talking to myself, but when I talk to myself, it's not going on.
Cool. You just get the shit.
I'm sorry. Guys, this is James from Mooshimeter Engineering. They make the Mooshimeter, which is a Bluetooth connected multimeter monitoring logging device. So definitely a lot of cool stuff here. A lot of there's a great video too of like monitoring your battery in your car while you're sitting inside. It's a really cool idea there. It works with I think iPhones and other stuff too. So and handouts. Yes. Not pass outs, but Oh, yeah. Sorry, figuring how to use this little tiny microphone. Is this an okay level? Okay. First thing I'm going to do is I have a bunch of meters with me, and I'm going to be talking about the product. So if you want to actually see it and feel it and do that sort of thing, then just pass these around and open them up, and I know how many there are, so don't steal them. Hi, my name is James Whong. I am the founder of Mooshim Engineering LLC, and about a year ago, actually about a year and a half ago, we started on this project. It was the Bluetooth wireless multimeter, and it became the Mooshimeter because it was the Mushi multimeter, and that just sort of matched together. But today I'm going to talk to you about some of the origins of the project, and then some of the. It's going to be basically a bunch of little nuggets of information. It's going to be sort of a schizophrenic talk, just all the little corners that you can afford to cut to make things a little cheaper. I've committed the #1 sin in giving a talk, which is that I don't know my audience very well. So please interrupt me if you have questions, if I say an acronym that you don't understand, or if I'm just stuttering too much. So why build a wireless multimeter? They were already on the market. They've been around for a long time. Basically, I've always felt the need to use one. The need is very, very real. These are just some of the things I've worked on in my career. Back in the day, I was working on an autonomous vehicle, and one of the problems with autonomous vehicles is it's very hard to, measure something on a moving vehicle that's far away from you, because you will get run over and you will die. And so it was then that I was like, oh, well, it would be really nice if I could monitor this from far away. And sure, there were detachable display meters, but I was a student at the time. And that was also back in the mid-2000s when, a smartphone was a BlackBerry. It was a very different time. I worked for Boston Dynamics for a while. All of these shots are from roughly 3:30 a.m., which is just the time for taking that kind of picture. I worked on the humanoid robots a lot, and it's very difficult to diagnose electrical signals on a moving robot, same as the vehicle problem. So ended up doing a lot of stupid stuff like hanging oscilloscopes off of working robots, watching them from far away. And over here is this is a giant robotic leg bolted to this column for another robotics project. This one was just a personal project, me and some friends. And same deal, there are a lot of measurements in the real world that are too dangerous to make up close. So once everyone started carrying around smartphones, it seemed very obvious that you should be able to connect to your smartphone and just use this as a display. So the key features were that it had to be wireless and rugged, because I wanted to shove this in engine compartments. Wanted to, put this on moving limbs. But once you start thinking about using your smartphone as a display, you realize there's a lot of constraints that exist on traditional multimeters that do not exist on your smartphone. For example, you're no longer limited to just one line of text, or you don't need a custom LCD. You have this whole big, beautiful screen to work with. So you can easily display 2 channels, and you can graph them over time. So having that measurement capability would be nice. Also, having an embeddable multimeter seems just pretty sensible that you want to be able to log data. So there's an SD card slot for that. Oh, and people always ask where the name came from. Mooshim Engineering was named after my mom's dog, which is the little dog in the corner. Figured the name is always going to sound stupid, so it might as well be something somewhat unique and meaningful. Okay, so why not build a smartphone multimeter 10 years ago? Well, the radio protocols just weren't really there. There was Bluetooth Classic, but a lot of people's phones didn't have them. And it was only about last year, or maybe mid-2013, that Bluetooth Low Energy started making its way into smartphones. And Bluetooth Low Energy it's going to take over the world. It is a fantastic protocol. It has almost nothing to do with Bluetooth. I think it was, I forget what it was called before, but it was an entirely different standard that just got wrapped in. So it's a pain to deal with if you're used to dealing with Bluetooth, but it does a lot of very sensible things that make it very cheap, very low power, and it has the throughput. Well, it has very low throughput, but for this kind of application, it's just about perfect. What's cool to note is, these are all very ballpark numbers, but if you have a Wi-Fi connected meter, which have existed for some time, one of the issues is that most Wi-Fi modules have a very high sleep current. And if you go down to Bluetooth, which is an order of magnitude lower bandwidth, and also an order of magnitude lower current, life gets cheaper. But these guys have unique disadvantages. Wi-Fi, you can only maintain one connection to your phone at a time. One of the nice things about Bluetooth Low Energy is it's a very low duty cycle radio protocol, so you can connect to several meters at a time, aggregate data in one place. Bluetooth Classic, the main reason I didn't want to use Bluetooth Classic, honestly, is the MFI program from Apple, which is an incredible pain to deal with. To make a Bluetooth hardware device that talks to an iPhone, not only do you have to comply by their software standards and get approved, you have to include their chip. They have their own authentication chip that they have to ship to you and you have to include in your process. It's an incredible amount of red tape. Bluetooth Low Energy, you can sidestep that. So upon cursory investigation and learning about Bluetooth Low Energy, it seemed like the time was right to go with it. The next big question everyone wonders about is, should you use a module, or should you go with a chip on your board and build your own antenna and radio front end and all that? Honestly, it really depends on your application and how many you're making. If you're making 1,000 of something and you need no further certifications, then I think it makes sense to use a module. Module prices have come down, but when I was looking at them, like the Blue Giga Bluetooth Low Energy module was around $10 a pop, quantity one, and CC2540 was much, much, much lower. Granted, for the if you're using a Bluetooth system on a chip, you have to put some crystals around it. You have to put bail-in antenna, stuff like that. But total cost for your radio core is going to be much less. About half.
So when you say no certi, they handle your FCC ID, but you still have to go through FCC compliance, right?
You have to,
Even with the module?
with the module, you get to skip a big chunk of it.
The FCC ID, right?
Getting an FCC ID is just a paperwork issue. You don't have to go through a
You
test.
still need to pass like unintentional radiator, right?
Honestly, I can't remember. You have to use something.
That'd be exempt under 15.
Testing measurement is exempt, but it has to be declared as such. If you're declaring it as a consumer item, it's a whole different story.
Okay, thank you. Yeah, I haven't been through this process in like 8 months.
You don't want to do it. Really.
But yeah, even if you go with a module and you want to, I think the next slide in my notes I say, I don't know, you still have to go through immunity testing.
You do? Not for US, for Europe, you do, not for
Yeah.
US.
And we're selling in Europe. So if you want to
yeah,
see,
Okay, well then the FCC cert's problem, even with the module.
Yeah.
Doesn't hold.
Actually, CE doesn't require it. The only time CE testing in CE is at the point at which they actually call you out.
right, it's a self-cert.
It's a self-cert, but you have to be able to back it up if you're called on it.
Exactly.
Right, exactly. But just to be clear, the FCC does require that you're actually certified module.
Mhm.
It's a different level of certification because they're going to verify whether or not making the radio is actually compliant.
Oh, yeah.
Yeah.
So you have to provide some sort of conformance testing that says, I haven't actually modified the radio circuit, which was previously certified by FCC. So the tier is the difference between $5,000 to get certified
But for CE, you have to do it all from scratch pretty much.
Yeah. He still requires that you do that, assuming that you think you're gonna get called on. But
You're taking chances then.
yeah, if you're taking chances and you're subject to.
If you get called out on it and you don't have the paperwork to back it up, you're screwed.
Right, exactly.
So it's just something you don't really want to do. Okay, so the other big part of a multimeter that people deal with is the connectors, and there's no real choice there. If you're building a pocket multimeter, some of them have integrated leads, but every serious multimeter has shrouded banana connector, and that's just the way it always has been. Now batteries are another key choice you have to make. A lot of consumer devices now all ship with lithium-ion batteries that are rechargeable and the ubiquitous micro USB port. But one downside if you're trying to get if you're building a measurement device, and especially if you're going for a high voltage rating, high voltage in this case being 600 volts, which is not really high voltage, but if you're going for a Cat3 600 volt rating, you need to withstand exposure to high transients of about 4,000 volts, I think, in this test. And the reason I mention that is that basically any connector you have becomes a liability. So if you integrate a lithium-ion battery, you have to put in a charging circuitry that's isolated from your measurement circuitry, and that's a big pain. Alkaline, their main downside is they're huge and they have to be replaceable. But the fact that the connectors are always sort of chosen, we have these big banana jacks, means that trying to optimize the size of the battery is a game of diminishing returns. So alkaline won out in this application. So a little bit of origin, I guess. Before the meter, I was doing a lot of contracting work, a lot of small companies building wearable nonsense, and this is the first board with a Bluetooth low energy that I built that I got familiar with, and a lot of the key parts of a multimeter are already here. I mean, it has the radio core, it has power management, and it has sensitive analog stuff. In this case, it's a skin galvanometer. Yes, pennies make excellent electrodes. Oh, and it also has an SD card for logging, which is convenient. So it was after building this that I started thinking a lot about converting it to a multimeter. The first revision of the meter is pretty darn minimal. It's since, like Mark pointed out, the design guy and the build guy are at odds with each other. And since I knew I was going to have to build these, I was very conservative. Everything's 0603, everything's huge. So this one is actually using the A to D on the CC2540 for all the analog stuff, which I was just trying to be as cheap as possible. And that ended up being a really terrible instrument. Yeah, it really can't measure crap. But it was a good learning experience, and it was a good start. It also had no protection circuitry, so if you hook this up to anything serious, like, it will explode. But it's a start. Oh yeah, and finding connectors is also surprisingly challenging. So these aren't even shrouded banana connectors. I just wanted something so I could order and start. So these are just regular banana connectors, and they're just awful and a giant fuse holder. So it's got this sort of awkward Frankenstein look. Revision B has real shrouded connectors. You'll also notice there's two. I have to lay out the next. Oh, no, I don't. Okay, I'll show you later. It also has two big divisions on the board. This is digital land over here, and then analog is over here,
and it's all divided, split plane. The A to D is pretty high-end 24-bit converter that, yeah, it gives pretty fantastic resolution. And it still has no protection circuitry, but I'm not going to give you the blow-by-blow on every revision, but it evolved over a couple of revisions. And the version that actually went into production was revision G. And yeah, a whole lot changed from the beginning. I mean, learning all about the cat tree requirements and the high voltage protection, you know. The top of the board basically became devoted to protection circuitry, and there were just a very few through-hole parts. So surface mount wise, almost everything is on one side of the board for ease of manufacture. And then there's a secondary process of putting in the through-hole components once it's assembled. But yeah, it's also very tightly integrated with the case. The cases, well, I'll go a little bit more into the case design later, but the connectors are not separate, they're integral. The contacts are custom designed and overmolded. Yeah, I went with transparent because couldn't pick a color. And yeah, to jump to something else, thinking about how to design for low power. So this product has no off switch. It's always on and it's always advertising and it's always connectable from your phone. Except the ones that I passed out, which are in hibernate mode, which is something else. Because you can't ship live radios to a lot of places; they get upset. So these have a hibernate mode that doesn't require you to open it up and poke it. But I digress. So in applications like this, where you have a very low duty cycle, most of the time the device is on, but it is sitting idly and waking up every once in a while to blast out a radio packet. That's what these do. They wake up once a second and they blast out an advertisement. In these cases, quiescent current dominates. In high power applications, you usually care about the efficiency of your power circuitry, whether you're getting 50% out of your switcher or 90%. In this case, quiescent is pretty much everything. So the absolute most basic way to do this is just take your batteries and hook them up to your electronics with nothing in between. Downside of this is that everything, even if it's off, is drawn into quiescent load. And you won't be able to get the full capacity out of your batteries. AA batteries are not 1.5 volts for their entire discharge cycle. They will drop down to 1.2 volts at about 60% of the discharge, and 1.2 is the lowest that you can run on, really. Sorry, 2.4 is the lowest you can run on. So you won't get everything you need to get out of your batteries, and you'll be drawing full quiescent. To get around the discharge issue, the first thing you might think of doing is putting a step-up regulator in there. That gets around the discharge issue, but it drastically increases your quiescent draw. Generally speaking, there are two broad classes of step-up regulators in this power range, and there's the inductive kind and the capacitive kind. And the inductive kind, even if they're not on all the time, the quiescent is usually several orders of magnitude higher than the processor itself. So this was not good enough. So the final power architecture ends up looking like this, which is good, which is much better for a whole number of reasons. So the radio and digital circuitry is the only part that needs to be on when it's in standby. So it can be powered directly off the AA batteries because it'll run down to, like I said before, about 2.4 volts. And the quiescent draw on these Bluetooth low energy system on chips is incredibly low. So the CC2540 is used in this. It draws about 1 microamp. Nordic has a very, very similar well, not similar design-wise, but occupying the same niche chip, Bluetooth system on a chip, similar power draw. So having that on all the time is very low draw. But you want to hide your analog electronics and your switchers. You don't want them on all the time. So you keep them separate, and you turn them on only when you need them. And to get around switching noise on the analog, if you're running precision analog off switch supply, that's generally bad news. So one way to mitigate that is you sacrifice some efficiency, and you just stick a low dropout regulator after your step up, and you basically just cut off the switching noise at the top. Oh, and one other benefit is that various SD cards don't run down to the same voltage. Some are happy at like 3 volts, some will run down to 2.5, but you can't rely on it. So one other part of the power architecture is that since they're digital and they're happy with relatively noisy switched power, they are run directly off the switched step-up converter. Yes.
How did you choose between Nordic and TI for your Bluetooth?
When I started designing this, it was early 2013, and TI's parts were already out with beta sheets available. Nordic's part, I think, was hidden behind some sort of wall that I didn't want to register for.
You just have to like it.
Yeah. So that was it. If I could do it again, I would go with Nordic's part. The CC2540 has a very underpowered core. It's an 8051 8-bit core, and it sucks for math. So when you're doing like RMS calculations, huge pain.
The LDO output was clean enough without additional filtering and the step-up regulator? Didn't need ferrite beads or something like that?
Oh yeah, there's some ferrites in there.
Okay, okay.
I just didn't include them on the architecture slide.
Okay, that's fair.
Mm-hmm. So low noise, high level design. Layout is super duper important, as you all already know. And the general strategy on the final layout was, separation. So all the radio stuff is over on one side of this planet, and all the analog stuff ends up over here. And the only signals that cross at the bridge are these are the SPI signals. And that's the only place where the ground plane connects. And the reason you want to do this is you just want to reduce any, you want to know where all your ground currents are going, and you don't want digital ground currents going underneath your analog parts. This is pretty basic analog design stuff, but yeah, it's very important to execute. Also, when you're routing analog signals, there's often a temptation, even if one end of your differential signal is ground, that doesn't mean you should rely on poking down at the ground plane to get your ground at your converter. You want to get your ground as close to the signal as possible, and then route it as a differential pair. So all these are the sensitive analog lines, and they're all pairs. And some of them are actually single-ended. One end is ground, but you want to connect to ground as close as possible to the signal itself. And another nice thing to do is to sandwich your long routing layers. So this is layer 3 on a board. Layer 2 and layer 4 are both ground, so they are pretty well shielded. So yeah, that gives pretty solid noise performance.
So just having the via and the single-ended trace, the start and stop, is enough? And we still want to run that ground trace as well?
Yeah, the main reason is if you have any currents flowing in your ground plane, then that'll show up as an offset near your converter. just the resistive drop. So yeah, like trying to think of a good way to give an example. Okay, so like over here, this is the current sense amplifier, and you know, it's drawing a couple milliamps. It's dumping its power back on the ground plane, so there's a couple milliamps flowing through the whole ground plane, going back to the left. The output, if it's single-ended, and you just sample it here and then sample the ground plane over here, you will end up seeing that power current multiplied by the resistance of whatever the plane is. So it's a couple microvolts, but it matters in this case. Let's see. So gotchas. All right. So one of the biggest gotchas that hit us in immunity testing was amplifier rectification. So this is a fun property of op amps. Most op amps with FET inputs are vulnerable to this problem. RF noise becomes rectified as a DC offset on the output. It's especially prevalent in high gain amplifiers like current sense amplifiers. So the way the Mooshimeter is built, there was some filtering on the current sense inputs, but even common mode RF noise can generate this, so it doesn't have to be a differential signal. A common mode RF noise will generate a DC offset on the output. So you just have to be super careful and filter liberally or conservatively. Filter a lot. So yeah, most of you have seen this kind of topology before. They're pretty familiar, but you know, it's definitely not overkill. This ended up being the filter topology for the common lead. So the way the Mooshimeter is built, the common lead coming out of the meter is hooked up to it's a voltage reference between the rails internal to the board. And one of the problems that was coming up in immunity testing was that RF noise, even though the Mooshimeter is floating, RF noise was still strong enough to infect the common lead and generate nasty offset errors. So the only reason I wanted to show this is this is a second order filter with, yeah, so there's ferrites, there's RF inductors. Basically take it seriously and model it. This solved the problem, but before, in the version that first went to immunity testing, there was, I think, like one layer of capacitance and just some resistance. But you know, ferrites and RF inductors exist for a reason. They're very cheap in quantity. It's worth it to model them. Another problem, I think I was already aware of, but had never been bitten by it before. A lot of designers just pepper 100 nanofarad caps everywhere, call it good. That's just it's convenient, you know, you only want one size of cap. It works when you test it on a bench. However, different sizes and different dielectrics exist for a reason. One of those reasons is that all capacitors exhibit a self-resonant frequency. This is the frequency at which the parasitic inductance of the capacitor and the capacitance itself will form an LC tank. And the quality of the tank is pretty low. It's not going to like ring forever if you poke it, but it means that it has very, very low impedance at that one frequency. So if you only use one kind of capacitor, you end up with this notch in your frequency response and vulnerability. So that's why you frequently see on high-speed digital designs and a lot of precision analog designs, you use a couple different kinds of dielectric and sizes and capacitances because they all have different self-resonant frequencies. mitigate the effects of each other. So now I'm getting a little bit more into like the manufacturing details of it. Right now there are 1,400 Mooshimeters in the wild. They were all made in my 10x12 office, and the way that is possible is that I was thinking from the outset about how to calibrate and test these. So pogo pins are a wonderful, wonderful thing. You know, if you buy microcontrollers, getting code onto them is always a question in quantity. Depends on the manufacturer how low they're willing to go in terms of quantity before you ship them a flash image and they'll send you 10,000 with the right image on them. But you know, if you build your own pogo pin rig and put all the pads in an accessible place, and you think about fixturing, it all becomes pretty manageable. This is the calibration rig that all the meters went through. It's a custom board that calibrated against a niche traceable multimeter. But so it's just pogo pins, and there's no external controller. The firmware on the meter itself has a calibration routine that will switch the it'll switch the programming pins to stimulate the calibration board and expose it to the various calibration values it needs to see. So thinking about fixturing, wood is your friend. Yeah, wood's great. Yeah, like this is the fixture that all the meters got held in for programming and calibration. It's just wooden, plastic, and screws. Yeah. Also low cost, importance, shipping. So if you're shipping domestically, USPS first class is always your cheapest option. 13 ounces is the cutoff for first class mail. To ship a meter in the US, first class costs $3.50. To ship it priority costs $7. So that cutoff becomes super important. So one of these things weighs 12.5 ounces. With packaging, it's like just shy of 13. So, you know, had that in mind from the beginning. It was weighing the bags things came in. It becomes very important. The weight of the label itself actually becomes important. So yeah, you want to stay below that. Doing fulfillment is a pain, but most fulfillment services are well, it depends. I haven't found one that's cheap enough yet. Let's put it that way. Label printers are wonderful. Stamps.com has terrible formatting issues, but otherwise good. More on fixturing. I mean, yeah, when you're designing your board, think about where you're going to grab it. If you handle everything in a panel, that's one way to do it. If you're handling them one by one, it's really important to have good holds for it. So in the case of this meter, building battery blanks and gripping through the contacts worked really well. So the enclosure itself, it was designed to be made in a straight pull injection mold, so no side actions, no funny stuff. And all you have to do to make your enclosure two-part moldable is you just have to be really aware of all your draft angles. And if you don't know what draft angle is, that's if you think from the perspective of the mold coming straight down, you need to be able to pull straight out and not have any overhangs coming in. So as long as you have sufficient positive draft on every face, you can make that happen. So yeah, extra actions in your mold become very expensive very quickly. So just avoid it.
You have your molds done here or in China? Or?
China. Overmolding is also it's a little intimidating in the beginning, but at least in this case, it gave really great results, really reduced the labor to put it all together. Labor compared to like ultrasonic welding or anything like that, or getting those inserts in there. So yeah, overmolding is also a good option for you. Consider it.
What is overmolding?
Oh, sorry. Overmolding is when you take the brass parts and you put them in the mold before you inject the liquid plastic. And then the liquid plastic will just bond to the surface or bond with little grooves that you cut in the part itself. And then it's just in there forever. And it's really great because it means you don't have to go in afterwards and like shove parts in. It's fantastic. And it's waterproof too, which is nice. But yeah, so, sorry. Any more questions? I have videos to show too.
Calibration is a one-time deal?
Calibration is a one-time deal, but you can send it back to me and I'll calibrate it again.
Okay, and you would provide a certificate of traceability?
Sorry?
You would provide a certificate of traceability?
No, no certificate is provided right now. I would like to do that in the future, but so far it hasn't been terribly important for people buying it, and it would be a pain.
Yeah, so these are industrial, a lot of industrial customers with parts in that.
Yep, and hope to serve them soon. It is traceable, but just haven't done the certification part yet.
Okay, fair enough.
Yeah.
How many cases did you have to order for the injection mold?
2,000.
2,000. And they did it in a couple of months. It was all pretty reasonable.
I think it took 6 weeks to cut the mold. It's steel, so I'm going to use it for the next run as well. And the production took, I think, 8 weeks. But that also included the machining of all the custom parts.
So they also were in charge of making the mold.
Yeah.
Were you worried at all that, the design might not work? Or
We had a little back and forth, but it was pretty minimal. They asked me to change just a couple of draft angles where it wasn't tight enough. And also, it's very, it gets aggressive near the connector. If you look at this picture, this was a problem we had in some of the initial shots in the mold. It's actually cracking near the connector because the walls get really thin, and the fact there's the overmolded part there, it makes it thermally very different from the rest of the mold. So there was some cracking. But no, it was just sending step parts back and forth, making changes. That part probably took about 2 weeks.
okay. And then did you hire someone to design the software on the phone, or how
Nope.
was that handled?
I wrote that too. It's my first iOS app, my first Android app. They leave a lot to be desired, but there's so much. You have to know so much about the meter to talk to it, because there's no documentation, of course. That hiring someone would require writing documentation. That's hard.
And last question, how much does it cost? You're not doing a good job selling it here.
Oh yeah, no, I'm not a salesman. It's a 120.
And how often can it take a measurement?
The ABC will run up to 8 pill samples a second. However, Bluetooth Low Energy is very limited in how much data you can push across the link. So yeah, you can get, honestly, it depends on the phone, because the phone sets the interval right. So 10 hertz, something like that. But it also can do averaging and RMS on the meter itself. So you don't have to wait for.
Can you save like a bunch of samples on the card and then get us just a subset of those on the phone?
Right now you have to take out the card.
Okay.
You can't stream the data over. It's, yeah, Bluetooth Low Energy on Android is turning out to be a massive pain, because it was only, I think it was only standardized in 4.3, which is relatively recent. And before then it was all manufacturer specific. And even though it's supposedly standardized now, there are still a lot of manufacturer specific differences. So that's turning out to be quite a pain. But yeah. So, more questions? Want to see some videos or something?
Data logging has landed in the firmware.
Data logging has landed with caveats. It's not released yet. Yeah, that's the issue. There is that yeah, like I said, if I could do this again, I would have used the Nordic part. It's quite a pain doing. Sorry, where was I going? Bluetooth Low Energy has very specific timing that it requires, and talking to SD cards also has its own timing requirements. I mean, you have only one core to talk to both of them. You end up conflicting a lot of the time. So, yeah, that is an issue that is being worked on.
Have you started talking to suitors? Do you already have suitors? Or is
No, right now everything's just sold on our website, and yeah, no distributors yet.
So you're talking smartphone around?
Way in the beginning. Sorry?
Or Saleae.
Or Saleae. Yeah, definitely considering it. It's just a matter. I mean, the crowdfunding campaign ran a year ago. Shipping only finished 2 or 3 weeks ago, and there's still some. Thank you. I'm still working on some features in firmware that were promised, but are not there yet.
So wireless bootloader then? You can
Mhm. They can upload firmware wirelessly. It takes a minute on iOS. It takes 8 minutes on Android. And the reasons for that are painful and very, yeah. But yes, it works. Let's see. Since we've been talking a little bit about manufacturing, would you guys like to see where the Mooshimeter is manufactured, the PCB at least? Let's see. Does sound work on this? No? Okay, that's okay. I'll provide a little bit. My speakers are woefully underpowered. So these are our friends, Sencor in South Dakota. Wonderful company. These are the parts of the process that Mark was just talking about. This is an automatic stenciling machine. It puts the solder paste down. It has a visual inspection system as well to make sure that it's in the right place, which, as Mark showed you, can be a problem. So after stenciling, boards get loaded onto a feeder where they go into the pick and place. And if in Mark's video he was running his machine full speed, it probably looked like this. I kind of wish there was sound because it's a very satisfying chunk. Oh, you have speakers. What? Oh, this thing. Incredible. Here. Oh, there's a microphone. Oh, what is that? That's exciting.
Help.
Tracy.
I'm not even professional.
Rev H.
I think I figured out the problem. Okay, we're good.
We'll move on to a masking operation, a stuffing operation, selective solder, and then board inspection.
Okay, I'm going to go back just a little bit so you can hear the wonderful sound that takes place.
From here, the panel will get loaded with views. Parts being placed onto the board. This angle is a little tougher to see, but the panel is in there.
It speaks for itself.
After the pick and place machine, boards will be going into the oven. Staging area. Waiting for the signal to be loaded. From here, the panel will move on to a masking operation, a stuffing operation, selective solder, and then board inspection.
So almost all the parts are on one side of the
Certain
board,
parts
but
being masked.
yeah. Now the sound is no longer satisfying.
What were they masking there?
They were masking, I think the connector holes.
Oh, for selective side.
Yeah, because the connector holes need to be clear. But yeah, the only parts on the back of the board are the big through holes and the SD connector. So I think.
Is that a wave solder process?
No, it's hand for the through hole stuff. Or no, wait, no, I think it's pin and paste for the through hole stuff, but the cleanup is by hand, and that's what this part is. So yeah, these guys are in South Dakota. They're the best. You should use them. I guess all right, I'm going to subject you to one more video because I didn't actually show you what the product is sort of about and what it does. So I'll show you the launch video.
The multimeter is the electrical thinker's Swiss Army knife. It's an indispensable instrument, but it hasn't changed much in 30 years. In the meantime, many of us have started carrying around small computers with massive displays and beautiful interfaces. Introducing the Mooshimeter, a wireless graphing multimeter and data logger that uses your smartphone's hardware to make difficult measurements easy.
Rugged construction means the Mooshimeter can go anywhere, making previously difficult measurements a cinch. The 24-bit converter has the precision for a bathroom scale to read the faintest touch, and the dynamic range to handle sturdy transients without the hassle and delays of auto-ranging. The 600-volt rating and wireless functionality gives you distance when you need it most.
The 2-year battery life and onboard SD card mean you can set it and forget it. Simultaneous voltage and current measurement lets you easily characterize power. And the 8 kilohertz sample rate extends these insights to AC applications. Diagnose power factor and harmonics with ease.
The Mooshimeter has an open API that allows it to talk to any Bluetooth smart device. And a smart device can talk to as many meters as it wants. Seeing relationships in a complex system has never been easier. We've built dozens of prototypes by hand and sent them out to testers all over the country to validate our designs and gather feedback.
Check out some of the example videos below to see Mooshimeters in action. We're ready to bring this device to market, and your pre-order will pay for tooling and volume discounts to make the Mooshimeter in quantity.
Thank you for watching.
Sorry? Oh, through Dragon Innovation, which no longer does crowdfunding because, frankly, they weren't a great crowdfunding site. They're a fantastic design consultancy, but their crowdfunding wing just never got traction. So anything else?
How many people in your group?
Just me.
Just you?
Yeah.
Who were those other 2 people that I saw in the movie?
Oh, those are my unemployed friends who helped me prepare. No, so calibrating and fulfillment. Yeah, I have some friends who come in either after work or when they don't have work, and we'll calibrate things in return for certain favors. Not like that. But yeah, no. The other voice you heard in the video was Eric Van Wyck, who gave very important feedback early in the process and also helped a lot to get the crowdfunding campaign together. But yeah, anything else?
What's the current limit of the meter?
Oh, the current limit? Internally 10 amps. Although the fuses, it'll go higher, but officially it's 10 amps.
You said there's no auto ranging. Is it fixed fixed gain everywhere? Is there no variable gain at all?
No, that's sort of a misspeaking in the video. It can auto range, and it does have different ranges. On voltage especially, you know, it can go from 2 volts to 60 volts to 600 volts. But in practice, you don't have to range very much because the resolution is such that you can set it to 600 volts and just, you know, measure what you're trying to measure. Usually people don't care about the extra digits. Very good. Thank you very much.
What's that? Yeah. I'm just unplugging his cable so I can walk past with that. Surfing over his VGA cable.
Thank you.
Oh yeah. See, the lab mic was a great success. For anybody who's come through it, so you know that I fought long and hard to get this flipping mics. And with outstanding feedback. Thank you guys both so much. That was really, really cool. We're going to do it again March 26th. So if people are interested in speaking, you should throw your name in the hat before we wrap up tonight or sometime reasonably soon. So we can go ahead and do that and get something lined up to actually have you come out and give a more detailed talk. I did mention that I had 3 books to give away. Somebody was kind enough to donate them. Little bird in the back of the room who works with the publishing company that actually published these books. So I have 3 books to give away. I don't really know. Does anybody have any creative ways for how I can give these away? I'm looking at you, Chris. Okay. Chris is normally social. Social.
Don't need this after, we'll put all your names in the hat.
Yeah, we'll do that. We'll do that. And then we'll pick them and then we'll give them out. Okay? Don't forget there are t-shirts in the back of the room. There are other things, stickers, all that other sort of stuff. There's snacks on the back table if you really want to take beer to go. Yeah, but thank you guys for coming out. If you want to hang out with us for a little while, by all means, you know, just hang out and chat, riff on stuff, whatever. Sorry?
Say not everyone's streaming.
Oh, it's streaming right now.
Yeah,
Puts me on camera in socially awkward moments like this. Okay, yeah. So thank you guys for coming out, and thanks again to these guys. Thank you for coming out. Thanks for the talk, and yeah, we can talk later about getting stuff into our store. All right, take care.